डियर स्टूडेंट्स, वेलकम टू एडुमिर फिजिक्स। आज के इस लेक्चर में हम डिस्कस करेंगे फोर इम्पोर्टेंट डिराइव्ड यूनिट ऑफ फोर्स, डिराइव्ड यूनिट ऑफ प्रेशर, डिराइव्ड यूनिट ऑफ वर्क डन और एनर्जी, डिराइव्ड यूनिट ऑफ पावर. So let's start from the derived unit of force. Force can be defined as mass into acceleration. We know that mass is a fundamental physical quantity, but acceleration is not. So we have to write acceleration in the form of fundamental physical quantities. So acceleration can be written as velocity by time, and further velocity can be written as displacement by time. So ultimately we are getting force equals to mass into displacement by time square. Hence the derived unit of force can be derived from this equation, because in this equation force is written in the form of fundamental physical quantities. Displacement is nothing but one kind of length. Okay, so this is also a fundamental physical quantity. Now the derived unit of force is unit of mass multiplied by unit of displacement divided by unit of time square. So it will be kg meter for the displacement and second square for the time square. So the derived unit of force is kg meter second to the power minus 2. We know a general unit of force as the Newton, and 1 Newton is nothing but the 1 kg meter second to the power minus 2. This is in SI system. So now the derived unit of pressure. The pressure can be defined as force per unit area. Now the force and area both are not the fundamental physical quantities, so we have to write these two quantities in terms of fundamental physical quantities. So force can be written as mass into acceleration, area can be written as length into breadth, and further acceleration can be written as velocity by time, and breadth one kind of length, so we can write length into length, that means length square, and mass is written as it is. Now the velocity can be broken as displacement by time. So ultimately we are getting the equation for pressure as mass into displacement divided by time square and length square. So all are these fundamental physical quantities. So the derived unit of pressure is the unit of mass, unit of displacement, unit of mass is kg, and unit of displacement is meter, and unit of time square, that means second square, then unit of length square, that means meter square. Then 1 meter will cut here, and then ultimately we will get the derived unit of pressure as kg meter inverse second to the power minus 2. This is also SI system. This is also an SI unit of pressure, and this is nothing but Pascal or Newton per meter square. Okay, Pascal or Newton per meter square can be written as kg meter inverse second to the power minus 2. This is the derived unit for pressure, and this is the derived unit for work done and energy. And here we have written the work done oblique energy, because the derived unit of work done and energy are the same. So work done can be defined as force into displacement, and we know that force is mass into acceleration and displacement is a fundamental physical quantity, so we don't have to break it. And acceleration can be further written as velocity by time. Now the acceleration can be written as velocity by time, and velocity can be written as displacement by time. So we are getting displacement into displacement, that means displacement square, and another time can be found from the definition of velocity. So and there is a time already, so we are getting time square. Hence the formula for the work done in terms of the fundamental physical quantity is mass into displacement square by time square. Hence the derived unit of work done can be written as kg for the mass, and meter square for the displacement square, and second square for the time square. And after simplifying we are getting kg meter square second to the power minus 2. This is the derived unit for work done as well as for the energy, and this is nothing but joule. In the SI system, work done has the unit of joule and energy also has the unit of joule. So 1 joule is nothing but 1 kg meter square second to the power minus 2. And the last one is the derived unit of power. So power can be defined as work done per unit time, and work done can be written as force into displacement, and time is a fundamental quantity, so we don't have to break it, and displacement is also a fundamental quantity, so we need to break the force into the fundamental physical quantity. So force can be written as mass into acceleration, and displacement and time are written as it is. And then further acceleration can be written as velocity by time, so we are getting time square here, and velocity can be written as displacement by time, so we are getting displacement square, and time cube at the here, because there is a time from the definition of velocity. So ultimately we are getting power in terms of fundamental physical quantity like this, and the derived unit of power can be written as kg for the mass, this meter square for the displacement square, and second cube for the time cube. And we are getting, finally we are getting the derived unit of power as this kg meter square second to the power minus 3. This is nothing but 1 watt. So watt is the general form, simplified form, and this is nothing but 1 kg meter square second to the power minus 3. So this is all from this video. If you find this video helpful, then please like it and share it with your friends, and do subscribe to get some regular important questions for your board exam. Thank you.